Welcome Geobase to the second installment of PACAF's Geometrical Constraint video series. If you have not viewed the first installment, Topology, or have not performed topologies, stop right now and begin there. Within our RBJs, run batch jobs, I am assuming that we have a topologically clean geodatabase. For instance, I'm not specifically looking for polygon overlaps within the RBJs. There really isn't a need when the topology does a much more efficient job. I do query the topology rule set with each RBJ. If any of the topology rules are broken, you will be notified within your reviewer table. Technically, I could have developed an all-encompassing RBJ, finding everything that our currently published topology can as well, instead of developing a separate topology rule set. But you will be missing all the automations that the topology engine can provide you. You will see in later steps that the topology engine can and will assist you, even in this data reviewer stage. As long as your topology rule set is within your table of contents and has been validated, you can use any of the topology tools to assist you in correcting an RBJ flag. For example, one could use the Align Edge tool on a topology toolbar here to fix a gap between polygons found by our RBJs. The 11 feature datasets studied here are the exact datasets examined by our topology effort. Any feature dataset that contains even a single KIP feature will have all its feature classes fully compared to one another. Before running a particular RBJ, remember to include all the feature classes that are included in the target feature dataset. For example, I have all the transportation feature classes that reside within my transportation feature dataset loaded for this demonstration. The current RBJs cover the following feature datasets: cadastre, general, hydrography, landform, military range, real property, recreation, security, transportation, water control, and waterways. What is currently lacking and will be developed in the future are all the utility feature datasets not yet officially published by HAF, which will include electrical utilities, fuel utilities, gas utilities, sewer utilities, stormwater utilities, and thermal utilities. As mentioned in the topology video, the KIP features classes' behaviors have been constrained to one another in this RBJ effort, even if they bridge across different feature datasets. If you remember, this is what topology could not do for you. I will go into this in more detail later in this video. Before opening the reviewer session manager, we need to create a new geodatabase within catalog to hold all of our data reviewer feature geometry and table flags. The location and existence of this geodatabase may be something that progresses in the future. Instead of having a localized geodatabase, we could have this centralized per base. Up on an ARC server, have the RBJs fire off automatically at a predetermined time, weekly, monthly, quarterly, and therefore have a centralized, all-encompassing quality control, quality assurance automated system. At our data reviewer toolbar, we're going to click on the reviewer session manager button. Now we are going to browse to the newly created local geodatabase that we just created. We are going to change our username due to the fact that it grabs our login name. This username field actually tags each data call within the data reviewer table. So if you have multiple people working on this and wish to track who has done what, have them modify this field appropriately. This is important for accountability in an ISO certified corporate entity for a production shop. Maybe not so important for us currently. Next, I'm going to click on a new session. And since we are viewing transportation in this video, I'll probably type in transportation in the field. Go ahead and choose spatial reference. Use active data frame spatial reference. We will most likely rename it in more detail later, but this is good for now. Every check within an RBJ that you decide to perform here will be outputted here in this session. More than one session can exist within a data reviewer geodatabase. As you can imagine, it's a great way to isolate particular calls and subcategories to make correcting your data more manageable and understandable. We will then hit Start Session. Within Catalog, you will now notice what the data reviewer has done to your geodatabase when starting a session. It has created feature classes where calls reside and coinciding tables for the data reviewer table. By the way, never modify this geodatabase outside a data reviewer session. It is highly corruptible if you do so this way. Now, I'm going to show you the advanced button and the ability to customize how the data reviewer writes calls and how the data reviewer table is visualized. The first tab, Reviewer Methods, drives how the data reviewer is actually writing its calls to the data reviewer database. Honestly, at this time there is absolutely no reason to modify it away from the defaults. What I want you to notice is the first checkbox is off. For this effort, do not ever turn it on. Now I'm going to hit the Table Properties button. Again, no reason to modify these away from the defaults for this effort. The only thing I would consider modifying would be the fields that the data reviewer table will portray. As you become more and more familiar with this table, you will learn what fields are necessary and what fields are not. The next tab, Defaults Checks, is one of more importance. Go ahead and check every call and hit Apply. Now remember that checkbox in the Reviewer tab? Continue batch processing if default checks return error. This is precisely why it defaults to unchecked. If for some reason later down the line, if and when we decide to run all these RBJs at one time with an automated script, none of these custom RBJs will run if these default checks are flagged. This is mainly due to the fact that most of these scenarios, invalid geometry check, multi-part line check, multi-part polygon check, nonlinear segment check, and polyline or path closes on self check, can and will disrupt some of our custom checks within our RBJs. For this current effort, I would go ahead and check all these default checks. I can think of only one scenario where you might want to keep multi-part polygon check off. And that is dealing with pavement branch roads. I know for a fact that the PACAF engineer guidance had you merge polygon roads if they maintain the same name and pavement across mainlines roads. I would suggest running all default checks at first, so that you can at least check your other polygon features. Then, if you know that the pavement branch roads is being called, come back to this tab and uncheck it. The same goes for polyline or path closes on self-check. Usually you do not want this behavior to occur, but in some instances, some bases have cul-de-sacs that exhibit this behavior. If you would like to preserve this behavior, follow the same techniques just mentioned for multi-part polygon check. The last two tabs, database properties and descriptions, have to deal with adding fields and descriptions for manual or custom QA/QC analysis. These are not needed at this time for this effort. Reviewer batch validate is where we're going to input our RBJs. Under features to validate, we're going to click the radio button, full database. Under batch job, we're going to click add from file. We're going to browse to our RBJ location, hit transportation, because that's a data set I'm studying right now. Hit open. Two things you'll notice here when fully uploaded. Reviewer processing errors. Due to the fact that RBJs holds checks for every feature class within our SDSFIE 3.0 template. We currently do not have all the feature classes that are listed within the SDSFIE 3.0 template in our current geodatabase, so therefore it is impossible to upload them into this ArcMap session. Because of this fact, the unable to update resources error is of no consequence in this scenario. Go ahead and click close. Second notice on the bottom left. Batch job was successfully updated to current workspace. Nothing but good news here. Next, we're going to go ahead and click validate all. This will disable all the checks related to features not found within the ArcMap session's table of contents. It'll also aggregate all the default checks that you enable back at the reviewer session manager. Note, it will always say validated with configuration errors, if in fact you are missing some of the SDSFIE 3.0 template feature classes in your ArcMap session. So here's where I have a major suggestion for all of you. For these initial efforts, with you the user becoming familiar with this extension and the checks I've supplied you within this RBJ, we're going to separate these batch jobs out in what I earlier mentioned, the Data Reviewer session, located back at the Reviewer Session Manager. If you remember, we named the session Transportation. And yes, you could theoretically run this entire RBJ in that session. In all honesty, once familiar with this process, you can go full throttle and load all these RBJs for every feature dataset into one monster session, as long as you have all of the feature classes and topologies in your map document that are called upon by the RBJs. For now, we're going to take it really, really slow. Let's go back to the Reviewer Session Manager and rename our session Transportation Database Validation Checks, just like the name of this first grouping 00. We're going to check off all the other checks except transportation database validation checks. Throttling back these calls will make it much simpler for you, the user, to comprehend what is going on for these preliminary efforts. Remember, if at any time a default check is broken, it will not proceed with any of the 038 checks here. So until cleaned up, the default checks will be listed in the initial transportation database validation checks session. No database validation checks will be initialized until all the default checks are fixed in the Reviewer Session Manager. Continue this process of creating a new session back at the Reviewer Session Manager for every feature dataset check numbered within our batch validate. For example, your next session would be transportation duplicate geometry check, your next transportation feature on feature checks, your next session transportation polygon checks, etc. Technically, you could progress keeping previous checks on, just in case you make modifications to your data that breaks these once again. Just note that these calls will be within your current session. Or you can isolate them down and keep them off. all of the 11 feature datasets listed out for you earlier share the same formatted 0 through 8 groupings. Some may be missing groupings due to the fact that they simply do not have that type of feature class involved in the feature dataset, mainly polygons and polylines. As mentioned earlier, the KIP features cannot have a topology rule set due to the fact that many of them live in different feature datasets. But some of them do. Take for example the transportation feature dataset. It holds many of our KIP features. The transportation topology rule set, along with the transportation RBJ, will actually be inadvertently controlling those that are considered within the KIP. By performing all the other feature datasets topology and RBJs before running any of the KIP RBJs, you will in a sense be completing most of them. The only flags that will be new would be those features that are not within the same feature dataset. I have created 2 KIP RBJs. One of them named KIP mock topology will simulate the topology engine within our arc map, meaning it will find polygon overlaps that should not exist, linear endpoints that should connect to a node and not an edge, etc. During mock topology, feel free to take care of the default checks during this stage as well. Theoretically, you could come across 0 flags due to the fact that every other RBJ run has already checked your data for default errors. The RBJ named simply KIP follows the same format as any other RBJ 0 through 8 groupings. To sum up this entire process, you'll need to run each step within each RBJ for each feature dataset one at a time, each in a different data reviewer session. I will provide you a list of sessions that you can follow in the video transcript. Then to conclude this effort, load all the KIP features within your Geobase to an arc map session, run the KIP mock topology RBJ, and finally follow that up with the KIP RBJ. I think we have thoroughly discussed how the default checks affect how the data reviewer writes to its table. If you'd like more information on what all the individual default checks are looking for, again, take a look at the ESRI help. This also goes for every preceding check that I'll be discussing. The database validation group includes 3 types of checks: domain check, relationship check, and subtype check. One painful note here: the SDSFIE 2.6 to 3.0 conversions through EGDEX does not translate domain values, meaning the old 2.6 values now exist in 3.0. These, of course, will not match the new 3.0 domain values and will need to be auto-calculated manually within your feature table. You will want to prepare each one of your 3.0 feature class tables attributes before running any of the domain checks. If this is not done, you'll receive tens of thousands of errors because every feature within your feature class will be flagged by this checker. This could potentially corrupt your data reviewer geodatabase. So take a step back, study your tables, and make sure all of your domains are calculated correctly before running this group of checks for a particular feature dataset. The duplicate geometry group includes 2 types of checks: duplicate geometry and duplicate vertex. Duplicate geometry is mainly there to check copy-paste errors. It may be somewhat redundant for a polygon and linear errors due to us already having topology checks for overlaps. It is mainly here to check to see if our point features are redundant. Duplicate vertex does exactly what it says, and I've actually configured it to do even more. Not only will it flag vertices that lay on top of one another, it will also flag inappropriate vertex densities. Currently, I've configured inappropriate densities at 1 meter, meaning you will receive a call within your data reviewer table every time you have a vertex that exists 1 meter from another. The act of weeding vertices is standard GIS practice and helps immensely with displaying your geodatabase. And of course, variable values within all of these checks described can be tweaked with additional input for all, some, or just one feature class. The feature on feature group includes one type of check: polygon overlap gap is sliver check. I have not configured this check to look for overlaps due to the fact that our topology rule set is already doing so. Note, I will be using this tool for overlaps with the KIP mock topology RBJ due to the fact that, it's impossible to have a topology rule set across those feature datasets again. Gaps will be detected, but only if there is one snapped vertex on each side of the gap error. So in this instance, you would not get a gap error. And here you would. Within each polygon gap sliver check, I have set the properties of maximum thinness ratio at 1 to allow the maximum width. Maximum polygon area is restricted to 200 to 200 square meters depending on the feature class in question, and this eliminates many exceptions. If you remember, the elimination of exceptions by limiting gap size is something topology cannot configure. Luckily, the data reviewer can. The polygon group includes one type of check: polygon sliver check. This check is mostly here to detect artifacts from users cutting and splicing existing data. Within each check, I have set the properties of minimum thinness ratio at 0 to eliminate long, sinuous features such as roads and taxiways from being called, and a maximum polygon area at 200 to 250 square meters. The polyline group includes two types of checks: cutbacks and length. Cutback checks for erroneous jags in data, mostly due from a shaky hand when extracting lines or some sort of geoprocessing cut, clip, split when dealing with polygons. Length check looks at all the polylines within the feature dataset and makes sure they meet the minimum length aggregated in the check. For each cutback check, the minimum angle size will vary throughout the RBJs, depending on the feature class in question. For each length check, I have set the properties of type polyline and length less than 1 meter. The table group includes one type of check: unique ID check. We're looking for attribute fields that must be unique. Object ID is compared within each feature class. SDSID, Spatial Data Server Identifier, is compared across the entire feature data set. The SDSID attribute has a type of GUID, Global Unique Identifier. A GUID data type stores registry-style strings consisting of 36 characters enclosed in curly brackets. It is highly recommended to turn off this check for SDSID if this field is still unpopulated within your feature dataset. If turned on and unpopulated, this RBJ will call out every single feature within a feature class. The topology group includes 4 types of checks: topology rules check, orphan check, unnecessary nodes check, and unnecessary boundaries check. The topology rules check will validate and cite any broken rules within the data reviewer table. If this check is flagged, I would highly suggest abandoning your current RBJ process and backtracking to form topology. Also note that this check is contingent on the fact that you leave your topology with the default name the topology wizard chooses for you upon generation. If you were to customize this name, the RBJ would not be able to recognize and run this particular check. If you customize the name, you will have to manually tie your topology via the workspace button here. The orphan check is for any linear feature class that will participate or has the potential to be in a network dataset, but type of feature class check should always be connected basically to a feature class identical to itself. The unnecessary nodes check is here to increase performance in our database. It finds a line-to-line connection where the called upon attributes are identical. So in this instance, a merge would be in our best interest. The unnecessary boundaries check acts identically to the unnecessary nodes check, except it is actually checking a polygon-to-polygon connection. A merge here would also be in our best interest. The geometrical connection not recommended group includes one type of check, geometry on geometry. The geometry on geometry check will call upon any relationships defined as not recommended within our SDSFIE version 3.0 Geometrical Constraints Excel spreadsheet. This spreadsheet will be part of your delivery for both the topology and data reviewer taskers. There are three types of tabs within. The first defines the primitive relationships that are defined by our constraints rules. The second type of tab is a matrix that defines what sort of relationship is occurring between two geometrical primitives within the 11 feature datasets that were studied. These primitives are surfaces, curves, and points. The third type of tab actually spells out and defines all of the constraints for a feature dataset.
I'm going to have all the databases. I plan on having all the databases set up by the end of next week.
The X character within the matrix tabs defines any connection between these two features as something that is not recommended. Within each geometry and geometry check, I have set the properties of spatial relationship, intersects. This will flag any feature that is touching the other in any way imaginable. Our last group, the geometrical constraints group, includes two types of checks, geometry on geometry and a composite. The composite tool enables us a way to fire off multiple geometry on geometry tools in sequential order, which allows a designer to find some pretty unique relationships. The geometry on geometry check allows the designer to call upon pre-designed spatial relationship checks or custom designed relations. The ESRI help describes these relations in detail under the heading Types of Spatial Relationships that can be validated. The spatial relationship heading should be examined thoroughly to understand what our custom relations will be checking. With the types of checks defined for the geometrical constraints group, we'll now delve into how each geometrical constraint is found. Again, the geometrical primitive relationships that are defined within the Excel spreadsheet tab, geometrical primitive relations, goes into these poly to point, line to poly, polygon to polygon relationships. The geometrical constraints tabs describes the specific feature class that experienced these primitive relationships. And they, in turn, can be referenced in the matrix. Is located at the edge of defines one geometric primitive relationship. Point to polygon. This point to polygon relationship is verified by using the geometry on geometry check. Spatial relation check touches find features not in this relationship. This flags point features that are not touching the boundary of your polygon. Is contained in defines three geometric primitive relationships: polygon to polygon, curve to polygon, and point to polygon. All of these relationships are verified by using the geometry on geometry check. Spatial relationship check within find features not in this relationship. This flags polygon, curve, and point features that are not within a polygon. Is located on defines one geometric primitive relationship: point to curve. This point to curve relationship is verified by using the geometry on geometry check. Spatial relationship check within find features not in this relationship. This flags point features that are not within a curve. Ends at or located on start/endpoint defines one geometric primitive relationship: curve to point. This curve to point relationship is verified by using the geometry on geometry check. Spatial relationship check touches find features not in this relationship. This flags curve or point features that are not ending on a point or not touching the nodes of a curve. Crosses defines two geometric primitive relationships: curve to polygon and curve to curve. Both these relationships are verified by using the geometry on geometry check. Spatial relationship check crosses find features not in this relationship. This flags curve features that are not crossing a polygon or not crossing a curve. Starts/ends at the edge of defines two geometric primitive relationships: curve to polygon and curve to curve. The curve to polygon relationship is verified by using the geometry on geometry check. Spatial relationship check relation. Custom spatial relation. The first character number is true, all the rest not checked. This flags a curve feature, not starting or ending at the edge of a polygon. The curve to polygon and the curve to curve relationships are also verified by using the composite check, with the two following geometry on geometry checks within. First, geometry on geometry. Spatial relationship check touches find features not in this relationship. This flags line features that are not connected to the boundary of the polygon. Second, geometry on geometry check. Spatial relationship check intersects with a tolerance of 2 meters. This flags line features that are not connected to the boundary of the polygon within 2 meters of the polygon in question. This narrows down the amount of exceptions generated by the first geometry on geometry check, so it doesn't flag every single line that does not touch the boundary of the polygon in question. Is connected to defines one geometric primitive relationship: curve to curve. This relationship is verified by using the composite check, with the following two geometry on geometry checks within. First, geometry on geometry. Spatial relation check touches Find features not in this relationship. This flags line features that are not connected to a curve. Second geometry on geometry check. Spatial relationship check intersects with a tolerance of 2 meters. This again narrows down the amount of exceptions generated by the first geometry on geometry check. Overlaps defines 2 geometric primitive relationships, polygon to polygon and curve to curve. At this time, there are no geometrical constraints that require an overlap. But remember, there are many topology rules that forbid this type of behavior. Is attached to defines 3 geometric primitive relationships, polygon to polygon, curve to polygon, and curve to curve. The polygon to polygon relationship is verified by using the geometry on geometry check, spatial relation check, relation. With a custom spatial relation, the first, second, and fourth character number is false. The fifth character number is 0, with the remaining character numbers not checked. This is finding a one-point vertex connection between 2 polygons. And this type of scenario is very common when dealing with long, slender polygons that are required to connect with only 2 vertices, such as roads and taxiways. This is what the polygon gap overlap is sliver check could not find for you. This scenario right here. Now is a good time to mention that not all of these custom relations can be outputted to the data reviewer table as feature geometry within our data reviewer geodatabase. Some actually give an error notice because of this fact, but there shouldn't be any worries. The call is still appended to the table, and a user can right-click the data reviewer row and actually select the working database feature in question. I will go into this later when touring the data reviewer table. The polygon to polygon relationship is also verified by using the composite check with the following 2 geometry on geometry checks within. First geometry on geometry, spatial relation check, touches. Find features not in this relationship. This flags polygon features that are not touching boundaries of another polygon. Second geometry on geometry check, spatial relation check, intersects with a tolerance of 2 meters. This again narrows down the amount of exceptions generated by the first geometry on geometry check. The curve to polygon relationship is verified by using the geometry on geometry check, spatial relation check, relation, custom spatial relation, the first and fourth character number aggregated true, with the remaining character numbers not checked. This flags line features that have an end of a line coalescing with the polygon boundary with the other end of the line outside the polygon. The curve to polygon relationship is also verified by using another geometry on geometry check, spatial relation check, relation, custom spatial relation, the fourth character number aggregated true with the remaining character numbers not checked. This flags line features that are within the polygon or cross the polygon's boundaries. The curve-to-curve relationship is verified by using the geometry on geometry check, spatial relation check, within, find features not in this relationship. This flag line features that are not sharing the same geometric space. Intersects defines 1 geometric primitive relationship, curve to polygon. At this time, there are no geometrical constraints that require an intersect relationship. This primitive relationship is being kept until after the utility feature datasets are developed. If the utility feature classes do not require this kind of relationship, most likely this primitive relationship will be removed. Near defines 2 geometric primitive relationships, point to polygon and point to line. Both of these relationships are verified by using the geometry and geometry check, spatial relationship check, intersect, with a tolerance of 10 meters. This finds point features that are not within 10 meters of the polygon or the line in question. Once all our RBJs are run, the reviewer table allows the user to right-click navigate through its calls, much like the topology error inspector. Those calls that do not have features associated with them within the Data Reviewer Geodatabase, due to custom spatial relations, do not have this option. These data calls can be browsed by right-clicking and choosing Select Related Row. With the attribute table open, a user can then right-click Zoom to. And of course, use Flash if you're still having trouble. Column grouping will help immensely with deciphering your data calls. By simply left-click dragging a column heading to the top margin, the reviewer table will sort by that column. So we have, you can see transportation 1, it's all 137 items are subcategorized into this one section. And as illustrated, the check title column may be the best group when checking the 08 geometry constraints groups data calls, just for this reason. You want to be able to pinpoint each individual rule and what I'm using to control that rule. Of course, symbolizing your data calls will always help you, the user, further decipher your errors in a more efficient manner. By clicking on the paintbrush icon on the left margin of the reviewer table, one can add a grouping of reviewer data calls and feature classes to the ArcMap sessions table of contents. One can customize this symbology just as any other feature class. Again, symbolizing using the check title attribute field for geometric constraints data calls is the most efficient way forward. You can see where you can symbolize any of these constraint calls that you want to customize as normal. And feel free to do that for lines and points as well. To manually flag a data call as being complete, simply right-click, enter correction status, and input appropriately. If you wish to delete your calls for some reason, clicking the pencil icon on your left margin will enable you to delete per row. Before moving on and doing any other edits, make sure to depress it again to save and close out the edit session. Since the Geobase program is not in the business of production per se, it is unnecessary to catalog correction technicians and verification technicians for external or internal QA/QC certifications. Feel free to reduce the amount of your finish calls by using the delete functionality once you've corrected every call. It'll make it a lot easier for you. The Select Run Data Check pull down on the Data Reviewer toolbar allows one to run a single check without using an RBJ. I'm going to build one of our most common composites for the rule is attached to polygon on polygon relationship. Going to input sidewalk A here under feature or object class 1. And within this field down here under build a composite check, I'm going to add geometry check. And I'm interested in querying up whether a sidewalk actually touches a airfield surface area. So I'm going to click airfield surface area. Spatial relationship check touches. And I'm interested in those sidewalks that do not touch. So, find features not in this relationship. And then I'm tag on an additional geometry check that is basically queried after that one check. And again, airfield surface area. And I'm going to restrict it to intersecting at 2 meters. So basically it's going to query up only those sidewalk areas that intersect within 2 meters to the airfield surface area. With everything aggregated within the composite check properties, I'm just going to click OK. Then simply click Run Data Check. I'm going to do that over the full database. I'm going to click OK to browse results. You also can write it to an existing reviewer table. As you can see, it provides you with an interface to browse the found data calls. So you can see there's a sliver between this sidewalk and this airfield surface area. You're going to have to go in here and snap it to the edge. You can imagine some of these get pretty tricky when you have more than one connection. Or a very small disconnect. So you can imagine this is the perfect way to test custom spatial relationships or composite checks, as I just illustrated. Or even an alternate way to pre-wash your database with known conflicts you're having problems with. The Reviewer Batch Job Manager allows one to build or modify all these RBJs just described in this video. Here's the Reviewer Batch Job Manager interface. You can see you have batch job contents up here in this field. I'm just going to simply click an example group. You can rename that to whatever. And you can see you can add checks just as I added a check back at the Select Run Data Check. They're all queried up exactly the same way. So if I wanted to add a composite check, I would build that composite check. Oh, forgot to put feature class 2. Give it a name. be added to my run batch job. Repeat this process for a full RBJ. All right, so the Geobase challenge. I'm going to be speaking off the cuff here. None of this will be on the transcript. I've got one problem that I can't resolve within our airfield surface area and roads and such under our transportation data set and basically any other data set. You can see here we have a parking area and it's attached fully on one side, but the second connection has a gap, right? If that gap was a 1-point polygon connection, I could find that with a specific spatial relation that I've designed that, you know, finds that 1-point connection. I think it's FFF asterisk F0 asterisk 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 whatever. You guys can look it up in the transcript, right? So checking this guy out, I can illustrate that our composite that's usually used to find a misattachment, right? You got your touches not, and you got your intersects within 2. Well, immediately it's gonna assume that it's a touching a road because it is touching a road on the side. So the next couple days, next couple of weeks, I'll be going in and out of the data reviewer and trying to find a way, either a composite check or a spatial relationship check to find this problem. Now the key here is to keep it within the RBJ. I could probably run an arc model, Python script, I don't know, to convert maybe this polygon's vertices to points, then run a buffer on that point to see if it, you know, intersects the road, yada yada yada. But that's going to leave a lot of exceptions when people have extracted a vertice on a real connection 2 meters away from the edge of that road. Yeah. There's a challenge. Good luck. I'll be doing the same thing.